Hello and welcome back to 4.9 homework. In the ready section, we'll write the formula for each measurement. Google this. And then do it. Find the perimeter and the area for the rectangle. So then use the formula. This would be like length. This is width. This is length or height. This is the radius, R. Length, height, width on this prism. They're interchangeable because the formula is multiplying the length times the height times the width. So when you're multiplying, you can multiply in any order, so it doesn't really matter which of those you call the length and which ones you call the height and which ones you call the width. Let's get on to the geometry. In the set, that was geometry. Let's get on to the trigonometry. Based on the given trigonometric ratio, sketch a triangle. Sketch a triangle. And find a possible value for the missing side, as well as the other missing trigonometric ratios. Label angles A and B as the two non-right angles in the right triangle. I believe this comma, what is that? Is a typo. Let's get real here. Yeah, the comma is a typo. So every one of these starts the same way. You sketch a triangle, you put a right triangle in there, you put an A and put a B. Then you can ask yourself, okay, if tangent A is 3/4, actually, I'm going to do a harder problem. This one. Right triangle, put an A, put a B. Cosine A is 12/13. That's all we know. Sketched my triangle. I got my cosine A. So cosine, there's cosine. Cosine is adjacent of hypotenuse. So cosine 12. Adjacent. What's adjacent? This is cosine A. What's adjacent to A? This side. So that's adjacent over hypotenuse. 12/13. The adjacent's 12. The hypotenuse is 13. Now we bust out some sine Pythagoras. Ironically, we talked about this yesterday. The side opposite an angle, it has the same name but lowercase. Oh, let's see, 25. Hey, I know what the square root of 25 is. It's 5. But now we can fill in the rest of the ratios. Because sine of A is opposite of A over hypotenuse, 5/13. And so on. So isn't it cool? From one trig ratio, you can then label your sketch, use Pythagoras, get the third side, and then you know all the ratios. There's a missing line here. Maybe we should do tangent of B because that line was missing. Okay, tangent is opposite side to, since we're doing tan B, opposite side of B over the adjacent side to B. Opposite of B is 12/5, 12/5. Opposite over adjacent, tangent, tangent B, B. And now you might be noticing tangent's the only one who can be bigger than 1. All the other ratios, sine and cosine, have the hypotenuse as their denominator. Hypotenuse is always the longest side. The denominator in sine and cosine are always the longest. So sine and cosine are always smaller than 1. Very cool. Tangent, however, can do whatever it wants. That's why it's the best. So do all of go, not all of go actually. This is optional for fun. This section. 9, 10, and 11. Okay, you gotta do this side though. Let's do 14. Not optional. I want to see your pictures of this one. Okay, so, ooh. Yeah, that's fine. Actually, I'm going to do the 13. So here's my angle. Opposite, hypotenuse. What uses opposite and hypotenuse? Oh, there it is. Opposite, hypotenuse, it's sine. So if I go look up the sine ratio for 73 degrees, someone will tell me what it is as a decimal. We'll write the decimal here. But also, in this specific triangle, it's b over 7. Let's figure out what b must be. Oh, great calculator. Look, it's in radians. See that little rad? That's bad. Hit this degrees, radians, gradients. We want degrees. Enter. Now it says deg. What's our degree? 73? In this calculator, you hit sine 73. Some other calculators, you hit 73 sine. Enter. Whoa. 0.95, 0.96. So all 73 degree right triangles, the ratio for the sine ratio for the angle of the 73 degrees is 0.96. Wow. Well, it kind of makes sense. I don't think, is this triangle to scale? Oh, I get it. The B side is almost as long as the 7 side. Whatever B is, it's almost basically 7. And it kind of looks that way. In fact, according to the lookup of this degrees it is 96% of it. In the specific case, though, we know that the hypotenuse is 7. So in this specific case, what would make B be the ratio of 96%, 96 to 100, 0.96. Time for algebra. This is why you learn algebra first. Even though geometry is older than algebra, algebra is a useful tool for lots of things. Well, let's get that multiplying dot pretty bigger. Oh, you can do it like this, and we get 6.72, or you can use the exact value. Answer times 7, 6.69. Compare that to our earlier answer, 6.72. Compare that to our later answer, 6.69. 6.69 is more accurate. So, use that one. All right. Oh, yep, that's it. Find the slope of each line. What else? We got anything good? Oh, 2 pages. We've done enough Pythagoras this year. Let's skip this section. And skip. Yay.